Okay, tonight we're going to continue working on the standard that we've been working on for quite a while. Tonight we're going to talk about inscribed angles. Remember, inscribed angles are simply angles whose vertex is on the circle on a diameter. A diameter is a chord that goes through the center of the circle, or right angles. So that's what we're going to be working with tonight. Here's our theorem. Remember, a theorem is just a math rule, all right? It says an inscribed angle, which is an angle whose vertex is on the center, subtends a semicircle. A semicircle is half the circle. Here would be half the circle. And remember, a half of a circle is 180 degrees. If and only if the angle is a right angle. So this angle has to be a right angle if the inscribed angle is on the diameter, or half the circle. And remember, that works because the inscribed angle equals half the arc. So, if we want to find the inscribed angle, that's going to equal half of the arc, which in this case is 180 degrees, because half a circle is 180 degrees. And we know half of 180 is 90, and 90 is a right angle. So anytime you have an inscribed angle on the diameter, you're going to have a right angle or a 90-degree angle. Here are our problems. Let's look at this. Here is our inscribed angle. We know it's an inscribed angle because it's on the circle. It forms the diameter. Here's my diameter. I know it's the diameter because it goes to the center. So I know this is 180 degrees. So that would make this a right angle. So if I want to solve for x, I'm going to say 4x plus 6 equals 90, because all right angles equal 90. And I want to solve for x. So to solve for x, what I need to do is I need to get x by itself. So I'm going to do the opposite of add 6. I'm going to subtract 6 from both sides. Positive 6 and negative 6 cancel. That gives me 4x equals 84, because 90 minus 6 is 84. And then to solve from there, I need to divide both sides by 4 to isolate the x. So 84 divided by 4 would be 21. So I've used the theorem. It says the inscribed angles will be a right angle if it forms half a circle. And I've solved for x. Here's another example. I've got my inscribed angle. I know it's inscribed because this vertex is on the circle. It forms a semicircle because this is the diameter. So this is 180 degrees. And half of 180 degrees is 90 degrees. So to solve this one, I'm going to set the angle equal to 90 because it's a right angle. I'm going to solve it. I'm going to get x by itself. So now I need to isolate the z. So I'm going to add 6 to get rid of the subtract 6. The negative 6 and the positive 6 cancel. So I bring down my 8z. I need to add is 96. And I divide both sides by 8. So 96 divided by 8 is going to give me 12. So z equals 12. Okay, this one's a little bit different. Again, I've got an inscribed angle. I know it's an inscribed angle because the vertex lies on the circle. It forms a semicircle because that's your diameter. It goes through the center. So I know this is 180 degrees because all semicircles are 180 degrees. That makes this the right angle. So there's several ways I can do this. If you go back to the right triangle unit, we said that the acute angles of a right triangle equal or complementary, so that means they equal 90. So I could say 6z minus 4 plus 30, because those are my two acute angles, have to equal 90. I want to combine my like terms. So my like terms here are negative 4 and positive 30. So that's going to give me 6z plus 26 equals 90. And if I solve for z, I'm going to subtract 26 from both sides. So that's going to give me 6z equals, those cancel, 64. Or is it 54? So divide both sides by 6. So 64 divided by 6 is going to give me 10.6 repeating. So z equals 10.6 repeating. And then basically the same example here. Again, I know I have an inscribed angle because the vertex is on the center. I know that it makes 180 degrees. So this is a right angle. These marks also tell me what? It tells me that it is an isosceles right triangle. So if it has two right legs, it's also going to have two congruent angles. So that's going to give me, this angle right here is also equal to 3y plus 6. And if I go back to my theorem that the acute angles in a right triangle are complementary, I can say 3y plus 6 is one acute angle. Add the other acute angle, 3y plus 6. And we know the acute angles are complementary, so they equal 90. If I combine my like terms, my y's are like, so if I combine the 3y and the 3y, that gives me 6y. If I combine my positive 6 and my positive 6, that gives me positive 12 equals 90. And all I have left to do is solve for x, so I'm going to subtract 12 from both sides. So that's going to give me 6y equals 78, and then I need to divide both sides by 6. So 78 divided by 6 is going to be 13. So y is to equal 13. So the main things you got to remember in tonight's lesson is that any inscribed angle that subtends the diameter, or a semicircle, is going to be a right angle. And then you're going to have right triangles. So work with that.